In this section, we're going to look at interpreting scatter plots. A plot is a type of graph we put on a grid, except we don't usually connect the points. We might draw lines of best fit, but we don't actually connect the points. So we got a bunch of definitions here. These will transfer not just into scatter plots, but into other types of graphs that we work with. So a scatter plot is just a graph with plotted points that shows any sort of relationship or a lack of relationship between those points. For example, we might have something like age and height, and then generally, as we get older, as our age increases, so does our height, just from basic observation. So we could have maybe points like this for a bunch of people. If we survey a whole bunch of people, we might get a whole bunch of points, something like this. People of all sorts of heights, but as in general, there's our scatter plot. We got a whole bunch of points scattered around. As the age increases, the height's increasing would be the relationship showing there. In terms of what a relationship is, it's just the pattern between two sets of numbers. So here we in general have an increasing relationship. Here there's not really any relationship. And here would be a decreasing relationship. And those are the general kind of descriptors for them. They're either going to increase, have no relation, or have a decreasing relationship. The independent variable is the known or horizontal variable. So we talked about on a graph that the horizontal axis is that x-axis, the one going down here. That's our independent variable. It's not, in general, generally we look at it as it's not affected by the other value. So if we look at, well, let's define dependent first, and then we'll look at the example. So the dependent variable is a variable affected by the change in the independent variable. It's the vertical value. So if we're comparing age and height, age does not depend on height. If you say, well, I'm 7 feet tall, that doesn't mean you're a specific age. But as you age, you will get taller. But as you get tall, but your height doesn't necessarily dictate your age so much as your age would more likely mean that you're taller, versus being tall doesn't mean how old you are. So age is the independent variable, and the height depends on that. Another one might be, say, the cost of gas for buying gas. So the number of liters you get compared to the cost of it. The cost, how much you pay, depends on how many liters you buy. In general, yes, you could set a dollar value. Say I'm only going to spend $5 on gas, but in general, the amount you buy affects the cost of the gas. So the amount you buy is the independent variable, and the cost depends on how much you buy. So that's kind of how those work out. Outline data is another concept. So there's times where there's points that just don't fit the general layout of the data. So you might have a graph, I don't know, of say, we'll go back to our ages and height here. And so in general, you'll have your points that kind of go up in a fairly linear fashion. They'll be a little staggered around in that. But maybe you have someone who is maybe super tall. And so at this age here, where people are normally this kind of height area, this guy's way up there and he's really tall. That would be an outline point. It doesn't really fit with the rest of the data, but it is a valid point of data. So when we hear the term outlier or outline data, that's what we're talking about. So again, there's a diagram of that. We got our outlier, and that should be I there. Dependent, independent variable. So this is decreasing values, and then there's this outline point that's kind of in the middle of nowhere. So for some examples, working with this, identify the independent and dependent variables in the following situations. So we're looking at the relationship between the time spent studying and the mark on your history exam. Well, in general, the more time you study, the higher your mark should be on the history exam. Now, this isn't exact because notice they're scattered around. They're not perfect on our points all the time. But it's a scatter. But in general, you would expect that the time you spend studying affects your score on your exam. So the independent would be your time studying, and then dependent would be your mark. In the situation where more people wear jackets as the temperature gets colder, so we have the number of people wearing jackets, and then the temperature. As it gets, the temperature is going to affect how many people wear jackets. If someone wears a jacket, it doesn't mean that it's going to get colder, but if it gets colder, it's more likely that someone will wear a jacket. So the independent variable is the temperature, because that affects how many people are going to wear jackets. So that number of jackets depends on the temperature. And then there's an example in the textbook here that I'll switch over to. So I'm going to slide over. We had section 3.1, show you know section. So here's the show you know section for 3.1. You see the show you know up here. So we're looking at number 2. And we want to identify the outline data on each scatter plot and what might have caused it. So I just didn't want to draw a whole bunch of graphs and make this a really, really long note. And my graphing skills are not quick on these papers. So identifying the outline data, well, it's fairly easy to pick out here. This one here doesn't really fit the line of values here. So there's outline data. But this is the speed of a skater going down the ramp. So this is their initial height on the ramp, and then this is their speed. And then this is the speed going down here. So starting at 4 meters, this guy here seems to be going fairly slow comparatively to everybody else. And so what could have caused that might be something like maybe the person got tripped up, or maybe they got scared and kind of slowed themselves down as they traveled down that ramp. Maybe they weren't going for that high speed. Maybe they were kind of nervous, something like that. In the case of these lizard temperatures, we have the surrounding temperature and then the lizard's body temperature. In general, as the surrounding temperature increases, the lizard's body temperature goes up. But here we have one that's kind of not matching with the rest. It seems to be lower in general. Maybe that lizard is sick. Maybe maybe it just came out of the shade, and so it was in a cooler temperature area and then stepped out into the warmer area when it got picked up to be measured or something like that. That could be a possible cause. Park attendance. So as the temperature increases, the number of park visitors seem to increase in general. But we got this point here seems a little lower, and this point here seems a little lower. This one not as much of an outlier, but this one definitely for sure is like there's less than 20 visitors versus nearly 80 when the temperature's 20. Here we got about 100 visitors compared to around 140. So what could cause those? Maybe weather. Maybe it was a rainy day. Maybe it rained for part of the day here. Maybe it rained all day here. Something like that. That would have decreased the number of visitors at the park. The size of a salmon. So here we see the longer the salmon gets, in general the mass is increasing. We do have this kind of weird guy here, this little outlier. Maybe he wasn't getting so much to eat, and it thinned him out a little bit or something like that. Could be a possibility there. Taxi requests. So here, we're generally kind of following this path here that as it gets warmer, we're going from minus 20 degrees out to up to 30 degrees. In general, we're kind of following this pattern where it's following this line here. This isn't really out of skew. It's a little bit warmer. More people are taking it. Maybe more people just want air conditioning here. In the case of minus 30, we got a crazy number of requests. If it's minus 30 out, maybe people are just not wanting to walk because that's pretty cold. Something like that would be a good descriptor. All right, back to our note. The last bit here, last definition, looking at the term trend, and that's just the general direction the values move from left to right. And so every time we've looked at these different graphs, if they're increasing, decreasing, we've always looked from left to right. When we read in English, we read from left to right and relate that to how you read your graphs. We always read from left to right. So this here would be positive and upward because we're reading from left to right. It's not downward because we don't read this way. We go this way when we read. So we're going this way on this graph. That would be our negative or downward graph, or decreasing. So increasing, positive, upward; decreasing, negative, downward model. And then one more example out of the book here, or a couple more, I guess. Let's just take a quick look here. Looking at the scatter plot on Show You Node 2. This is on page 109, by the way. So we got a scatter plot here. It shows the relationship between the profit from a school dances and the number of days advertising. So the general look here is that we're the more we advertise, the more money we make. Here there's a little kind of skew, but in general it seems to be the more we advertise, it's increasing fairly quickly. So it asks us, what does the point 5608 tell you? Well, 5 and 608 is that on one of the occasions, they advertised for 5 days and made $608. That was the number of days. That was the profit they made that day. So that's a specific day. What do the points below the horizontal axis represent? So down here, we're below the horizontal axis. What do they represent? Well, the profit's negative. They lost money on these dances. What profits represent dances with fewer than 5 days of advertising and less than $500 profit? Well, we kind of block off on the graph here. So under this 500 line right here, and fewer than 5 days, so not that point. So these points here, all these points below here and down here, those all represent fewer than 5 days and less than $500. The trend, well, if we look at it, as we said earlier, in general, the more days you advertise, the quicker the profits increase. Describe the relationship between the number of days and the advertising the profit. As you increase the number of days of advertising, the profit will increase. Something like that would describe the relationship, that trend. And then would it be reasonable to extend the trend to predict the profit if when a school dance is advertised over a 10-day period? Well, they haven't advertised more than 1 week for a dance by the looks of things. There's 7 days here. Could we extend that relationship and say that if we went to 10 days, they would make that much more money? Possibly. Depends on the size of the population they're pulling from. If this is kind of your max number of people that you can fit in the building, then no, you couldn't have any more than that's how many people they come in and make money from. In general, that's probably where they're making money, is the more bodies in there. So that might cap the number of bodies. But yeah, we could say this could continue and we could be making more money if more people attend. Just depends on the specific situation. So when we're modeling things like this, we need to take some different variables into account, like how big is the place. I mean, if you can only fit so many people in the gym, and these represent times when the gym was full, I don't know how much more money you might make. The next one here is a newspaper article about fat and calories in fast food includes this scatter plot. So we have this scatter plot. We got different fast food items, including their fat content and the number of calories contained within. So that's just what does the point 2,387 represent. And so we go 2,387. That would be the fries here. So that is the French fries having 20 grams of fat and 387 calories. That's what that point represents. How much fat and calories are in the chicken salad? Well, chicken salad has 15 grams of fat and 400 calories. And we can just use the points on the graph to find that. What points represent foods with at least 30 grams of fat and more than 600 calories? Well, at least 600 or 30 grams of fat means we're looking at points past this 30 line here, and then more than 600. So there's our 30, there's our 600. So the sundae and the cheeseburger are the only two that are above that. That onion rings is actually below 600 there. Describe the trend. In general, the more fat content of an item, the higher the calories are. It's going an increasing trend here. So that's the trend is that it's increasing, and then the relationship is that the more fat contained, the more calories you'll find. And then could this trend be used to estimate the number of calories in a deluxe hamburger with 65 grams of fat? Well, our cheeseburger here is sitting at just about 47, 48, and just under 800. 65 grams up here. Yeah, we could probably say that the deluxe hamburger, which would probably have more material on it that could increase the calorie content. So yeah, we could use that as a good example and say, yeah, we could estimate maybe a deluxe hamburger is going to have around 1,000 calories. If I'm kind of following this general line somewhere, 65 hits around here at 1,000. So yes, we could use that to describe the number of calories in a deluxe hamburger with 65 grams of fat. All right, so that's everything in terms of scatter plots that we're going to cover. Again, just a lot of definitions and really understanding how to read the graphs. That's the most important part. So if you can read the graphs, that'll set you up for success moving forward into some other units as well.